Alright, and welcome to our absolute value solving review. Now, in our very first example, notice that whenever we see these vertical bars, these are what we call absolute value bars, which of course we can abbreviate absolute value as ABS. Now, we don't know if whatever is inside the absolute value is either positive or negative, and the reason we don't know that is because absolute value bars make everything positive. So if y is initially positive, then it stays positive. However, if y is initially negative, then it goes to being negative. So you can kind of think of it like this. We could say, you know what, we have a negative y is equal to positive 8, and we have a positive y is equal to positive 8. What does that really mean? It means that we could say that y is equal to negative 8 or positive 8. So basically, whatever the absolute value bars are equal to, we'll set that equal to a positive or negative version. Okay, so for example, right here, in example 2, since we have the absolute value bars are all by themselves, we have to set this 9 equal to a positive or a negative. So we're going to do this. We'll do 2x plus 3 is equal to negative 9, and we'll also do 2x plus 3 is equal to positive 9. So we just take that 9 and set it equal to both a positive and a negative. Now from here, we'll just follow all of our solving rules. So we'll subtract 3 from both sides. Of course, negative 9 minus 3 is negative 12. And then we'll divide both sides by 2. And here we get x is equal to negative 6. And over here, we can subtract 3 from both sides. And we'll get 2x is equal to 9 minus 3 is 6. We divide both sides by 2. And 6 divided by 2 is positive 3. Okay, so here are two examples of where we can see absolute value having two solutions. Let's go ahead and look at a slightly more difficult example. Okay, for example 3, I want y'all to notice this. Here, the absolute value bars are not by themselves. In fact, what we can see is we can see that there's a 5 and a positive 7 on the outside of the absolute value bars. So we need to get rid of everything outside the absolute value. Let's just write that. Everything outside of our absolute value bars. Okay? Now we're going to do this by treating this almost like x. For example, if I were to say, if we were just to imagine 5x plus 7 is equal to 27, what would be the first thing you would do? Well, you would subtract 7 from both sides. Here, we'll do the same thing. We will subtract 7 from both sides. Now let's see what we have left over. We now have 5 absolute value, x minus 8 is equal to 20. Now notice that from here, we're still trying to get rid of that 5, and we will divide both sides by 5. Reason being, when two things are side by side, they're being multiplied. So once we divide, that goes away. And now we have this. We have the absolute value of x minus 8 is equal to 20 divided by 5, which is 4. Now that our absolute value bars are the only thing over here, we get rid of them by making this positive 4 plus or minus. So we really have two solutions here. We have x minus 8 is equal to negative 4, and we have x minus 8 is equal to positive 4. And to finish this, of course, we'll add 8 right there. We'll add 8, and negative 4 plus 8 is equal to 4, comma, and here we'll add 8, and 4 plus 8 is 12. So our solutions here will be 4 and 12. All right, let's go see one final problem. Okay, in example 4, you'll notice that this is a little bit trickier because even though we have the absolute values on the left, you'll notice that there's an x value right here on the right. Now here we'll do the same exact trick that we've been doing, except for now we have to put this entire expression in terms of plus or minus. Now how does that really change things? Well, we know that we get rid of our absolute value bars, and we have 3x minus 10 is equal to, and on the right side we have the negative version of 2x plus 8, And then we also have 3x minus 10. Remember, this never changes, is equal to the positive version of 2x plus 8. Now notice, all that's really saying is that this plus or minus has to then distribute. With a negative in front, it's like distributing a negative 1. So we'd say 3x minus 10 is equal to negative 2x, because a negative times a positive is a negative, and a negative times a positive, again, is a negative. Alright? Okay, now from here we have 3x minus 10 is equal to, we distribute our positive, and of course multiplying anything by a positive keeps it the same. Now from here, guys, remember, what's our rule? Always try and move this smaller of the two x's. So, if I want to do that, I will add 2x, I will add 2x, and 3x plus 2x is 5x minus 10 is equal to negative 8. Well, I will add 10 to both sides, and now I have 5x is equal to 8, or negative 8 plus 10 is 2, and when I divide both sides by 5, my first solution is potentially 2/5. Okay, next on the other side, we know that we'll move our smaller x, so minus 2x, and this will of course give us 3x minus 2x is x minus 10 equals positive 8. If we add 10 to both sides, we'll get x is equal to 8 plus 10, or 18. So that's how you will do these two different examples. Alright guys, I'll see y'all in our next video.